Hello guys, myself Isacc, Excel Chemistry. See, we are coming back again with the rapid focus area. Today I'm focusing chapter called amines. Okay. Regarding amines, I can say the respective areas are in nomenclature, preparation of amines, as you know, Gabriel thalamide, nitro compound, cyanide, Hoffman, bromamide reactions and all. That's all coming in preparation of amines. Then physical properties of amines including solubility, boiling point, that all covering in that area. They'll be switching into the chemical properties of amine. You may know it, basic nature, carbyl-amine reaction. Let's see one by one. And finally, we'll be land on with the disotization, coupling reactions and all, right? Let's see the previous board questions coming in these areas. I just chosen one or two questions from each areas. I think this video will be useful for you, right? Question number 1. Write the IUPAC name of the following compound. Regarding the IUPAC name, amines may be primary, secondary, tertiary. Primary amines are represented by RNH2, whereas secondary amines are represented by R2NH. Finally, tertiary amines are represented by R3N. Here my question. Write the IUPAC name of the compound. The given compound is actually CH3NH. Given compound is CH3NH. CH3 twice. See guys, regarding the IUPAC nomenclature or whatever may be, try to expand the molecule to max before starting the question, to avoid the confusion regarding the long chain. You may an expert, but according to me, since you are in grade 12 right now, better to expand it and think about the nomenclature, think about the long chains are okay. So in this question I can say CH3NH, CH3NH, CH3 twice. Expand it. CH3 twice means surrounded by 2 CH3. Regarding the IUPAC nomenclature, rule number 1 regarding amines. Okay. Identify whether your amine is a primary or secondary or tertiary. I can say regarding primary amine, we'll be having NH2 category. Secondary amine is called as NH category and tertiary amine is called as N. Here my amine is having NH. NH means belongs to secondary amine. Regarding secondary amine, mask the lower alkyl portion. Here my lower alkyl portion is methyl containing only 1 carbon. Here contain 3 carbon alkyl portion. So I can say lower number is methyl. Mask this lower number of carbon. Call this NH as NH2. You can call this NH as NH2. Give the name as such. Regarding the naming, if it is rule number 1, choose whether it is primary or secondary or tertiary. Since NH means I can say my molecule is secondary. Regarding secondary amine, mask one lower alkyl portion. Here lower one is containing 1 carbon portion. Calling this NH as NH2, give a name as such. You can say here long chain containing 3 carbon. Second carbon having amine. So name of the compound will be propan-2-amine. Name of the compound will be propan-2-amine. In addition to that, since secondary amine, there will be having 1 lower alkyl portion masked where there will be having 1 capital letter N hyphen. The masked one is called as methyl. So name of this compound will be N-methyl propan-2-amine. Hope you are fine. Regarding the IUPAC nomenclature, choose whether your compound is, whether amine is primary or secondary or tertiary. In this case, my amine is secondary. Since it is secondary, mask 1 lower alkyl portion, that is left side containing 1 carbon. Give name as such. It will be, propan-2-amine. After that, put 1 capital letter N. The masked one is called methyl. So name of this compound will be N-methyl propan-2-amine. Hope you got. Question number 2, please. To again the same category, write the IUPAC name of the compound, right? The given compound is CH3, N, again a CH3 which is connected to a benzene ring, right? Regarding again the same rule, please. It is primary, secondary, tertiary, N. Since N means belongs to tertiary. If tertiary come, mask 2 lower alkyl portion. The 2 lower alkyl portions are here methyl and methyl. If it is tertiary come, N means tertiary category, NH2 means primary. NH means secondary, N means tertiary family. Since tertiary amine mass 2 lower alkyl portion, the 2 lower alkyl portions are methyl and methyl. Call this N as NH2. So name of the compound will be benzene ring with NH2 called as famous aniline, right? Benzene ring with NH2 called as aniline. Then since there is 2 masking or 2 lower alkyl portions, there will be having 2 capital letter N. There will be having 2 capital. Since both of them are same, so we can say methyl and methyl, so called dimethyl. Since both of them are methyl, I'm calling methyl and methyl called as dimethyl. So there is 2 masking, so called NN dimethyl aniline. Calling NN dimethyl aniline. Hope you are fine, I guess. So it's again a IUPAC question regarding the IUPAC nomenclature of amine mass 2 lower alkyl portion. The 2 lower alkyl portion, since it's tertiary amine, there will be having 2 lower alkyl portion. The lower alkyl portions are methyl and give the name as such, it's called aniline, right? Since two maskings are same, since 2 lower alkyl portions are same, I can say methyl and methyl, so called dimethyl. Since there is 2 lower alkyl portion masking, there will be having 2 capital letter. That means regarding the IUPAC nomenclature of amine, we are calling it as alkanamine. If there is no capital letter N, means belongs to primary. If there is 1 capital letter N, belongs to secondary. If there is 2 capital letter N, belongs to tertiary. Hope you are fine. Regarding the IUPAC of nomenclature, if there is no capital letter N, primary amine, alkanamine, methanamine, ethanamine, propanamine, butanamine. If there is 1 capital letter N, belongs to secondary amine. If there is 2 capital letter N, belongs to tertiary amine. Now it's time for Hofmann bromamide reaction and carbyl amine reaction. What's meant by Hofmann bromamide reaction means RCONH2 called as acidamide. RCONH2 called as acidamide when passed over bromine in presence of NaOH. Same as bromine in presence of KOH, may be called like NaOBr, KOBr, same genre, right? So what is meant by Hofmann bromamide reaction means RCONH2 called as acidamide when passed over bromine in presence of NaOH, same as bromine in presence of KOH, resulting in the formation of RNH2, called primary amine. Byproducts are NABr plus Na2CO3 plus water. See guys, during conversion reaction, there is no need of minor, but during what is meant by Hofmann, byproduct is a must. During conversion reaction, skip about the byproduct, but if what is meant by Hofmann come, byproduct is a must. Anyway, it's called as Hofmann bromamide reaction. So during Hofmann bromamide reaction, acidamide called as RCONH2 will be passed over bromine in presence of NaOH, same as bromine in presence of KOH. What happened means I can say that CONH2 will become simply NH2. That means acidamide will become primary amine. Cool. That's called as Hofmann bromamide reaction, may also called as Hofmann bromamide degradation reaction. Why it is called as degradation? Because number of carbons getting decreased over here. What is meant by carbyl amine means it's applicable for primary amine. Only primary amine, maybe aliphatic, maybe aromatic, cool, right? Anyway, it's applicable for primary amine. When passed over chloroform and KOH, especially alcoholic KOH, chloroform and KOH, what happened means NH2 will become NC, NH2 will become NC, where NC means isocyanate, may also called as carbyl amine, giving foul smelling, bad smelling one, right? So what is meant by carbyl amine reaction means primary amine, applicable for primary amine. So during a carbyl amine reaction, primary amine may be aliphatic, may be aromatic. When passed over chloroform in presence of KOH, alcoholic KOH, what happened means NH2 will become NC, NH2 will become NC, NC means isocyanate, carbyl amine having a foul smell, bad smell, right? Byproducts are KCl and water. That means I can say Hofmann bromamide reaction is a preparation of primary amine, whereas carbyl amine reaction is a reaction of primary amine. during Hoffman bromamide reaction, we are getting primary amine, whereas carbyl amine is a reaction of primary amine. Hope you're clear. Like I said, it's Hoffman bromamide reaction. Acidamide called RCONH2 will be passing over bromine in presence of NaOH, same as bromine in presence of KOH. That CONH2 will become simply NH2, I mean primary amine. Why it is called as degradation? Because one carbon getting decreased over here, right? Anyway, that's called as Hoffman bromamide reaction, whereas carbyl amine reaction is primary amine of the category RNH2. When passing over chloroform and KOH, NH2 will become NC. NC means isocyanide. Carbyl amine will be giving foul smelling, bad smelling one, right? Let's see how the possible goes from this category, right? You may know, these kind of questions are called as word problem, right? Whenever word problem come, create a flow chart, but then think about the question. Whenever word problems are coming in your paper, expecting word problem usually coming from either aldehydes, ketones, or from amine. Usually the toughest areas of organic chemistry are believed to be the what we can say word problem, right? Regarding word problem, usually question will be coming from either aldehydes or amines. If questions coming from amine, you will be safe zone because silly only, right? Question is ready for you. Anyway, whenever word problems are coming, create a flow chart and think about the question. Okay, let's see how to approach a word problem. Compound A compound A on reduction with iron, scrap and hydrochloric acid. Iron, scrap and hydrochloric acid means iron HCl, right? Compound given, a compound A reduction with iron, scrap and hydrochloric acid means Fe in presence of HCl. Fe in presence of HCl. Gives a compound B having molecular formula C6H7N, having molecular formula C6H7N. Compound B on reaction with CHCl3 and alcoholic KOH produces an obnoxious smell of carbyl amine, produces an obnoxious smell of bad smelling carbyl amine due to formation of C. Identify ABC during these kind of questions, which is familiar for you. First of all, it's called as word problem. Create a flow chart. A to B, B to C. Fine. A to which is familiar for you. A to B or B to C? B to, because B to C is called what? Carbyl amine. So I can say whenever A to B to C to D to such kind of question coming, which is familiar for you. A to B or B to C? Your answer will be B to C because I know B to C is called what, guys? Carbyl amine reaction. Who will undergo carbyl amine reaction? Carbyl amine reactions are given by primary amine. Primary amine means RNH2. And during that carbyl amine reaction, primary amine, when passing over chloroform and alcoholic KOH, NH2 will become NC, right? Where NC is called as isocyanide or carbyl amine. Okay, cool. Who will be A? Someone A. Passing over Fe in presence of HCl, giving RNH2. Who is that? Someone A. Passing over Fe in presence of HCl, iron in presence of HCl, tin in presence of HCl, H2 in presence of platinum, palladium, nickel, giving NH2 is called as nitro compounds, because I know RNO2 called as nitro compound. When passing over Fe in presence of HCl, tin in presence of HCl, H2 in presence of platinum, palladium, nickel, can convert NO2 to NH2. So my A will be NO2 here. So we can say we can land over that. Somehow it's okay, right? Now who will be R here? See, in word problem, if 6 or more number of carbon come, think about a benzene ring. It will work almost 95, not 100% question, almost 93 to 95% this rule will work. If there is word problem having 6 or more number of carbon, not for whole, but around 94-95% question, I can say if there is 6 or more number of carbon come, think about a benzene ring. So here 6 carbon, think about a benzene ring. Then cross verify by using the formulas. So R will be supposed to be benzene ring. So I can say it will be benzene ring with NO2 called as nitrobenzene. It will be benzene ring with NH2 called as aniline. It will be benzene ring with NC called as iso. You can confirm the ring is correct by using the formula here, right? You can verify from here, guys, because I know benzene ring is equivalent to C6H5 phenyl ring or C6H5 connected to NH2. So number of carbon 6. Okay, number of carbon 6. Number of hydrogen 5 plus 2 called 7. Cool, right? 1, and so formula is okay. That means your answer is correct. Let's see one more question. An aromatic compound A, aromatic benzene ring, right? An aromatic compound A, having formula C7H6O2 on reaction with the aqueous ammonia, aqueous NH3, and heating forms a compound B, Beyond heating with the bromine and alcoholic potash. Potash means potassium hydroxide. Alcoholic potash. Potash means potassium hydroxide called KOH. Forms a compound C. With the molecular formula C6H7, which we are calling it as word problems, right? During word design should be like A to B, B to C pattern, which is familiar for you. A to B or B to C. B2C, because what you can say, B2C is called what? Bromine in presence of NaOH. That bromine in presence of KOH is called what, guys? Hofmann-bromamide reaction. Who will give that? Hofmann-bromamide means it's acidamide. So I can say B will be acidamide having formula RCONH2, and I know during that Hofmann-bromamide reaction, CONH2 called as acidamide passing over bromine in presence of NaOH. Bromine in presence of KOH, that CONH2 will become NH2. Hope you are landed right. The thing is that, in this kind of word problems, A to B, B to C, C to D, D to, which is familiar for you, start from there. I can say here my A to B, B to C. B to C is familiar one called as what? Hofmann-bromamide reaction. So go with that one. And I know this Hofmann is given by acidamide, and acidamides are represented by RCONH2 when passing over bromine in presence of KOH. CONH2 called as acidamide will become NH2. Then who will be A? Someone A passing over aqueous ammonia getting CONH2. Carboxylic acid, right? Someone A passing aqueous ammonia, passing NH3 giving CO. It's acid, it's carboxylic acid. For example, RCOH called as carboxylic acid. When passing over aqueous ammonia, this OH will take H from here, removed as water. Remaining will be CO. From here OH is gone. From here H is gone. Remaining is RCONH2 called as acidamide. Someone A passing over aqueous ammonia getting acidamide means carboxylic acid, because I know, guys, when COH called the carboxylic acid passing over ammonia, this OH will take H from here, removed as water. Remaining will be CO. H is gone. From here H is gone. Remaining is NH2. Collab gets CONH2 called as acidamide, right? And this as now think about who will be R. Same logic. 6 or more number of carbon come. Think about it. Will work only for 94-95 post question. Anyway, it's word problem. I can guess. Containing 7 carbon. Think about a benzene ring. Okay, so supposed to be a benzene ring. It is benzene ring with the COH. Again benzene ring with the CONH2. Again benzene ring with the NH2. Cross verify please by using the formula, right? Cross verify by using the formula. Formula is ready here. Benzene ring is equivalent to C6H5 connected with the NH2, right? Number of carbon 6, okay, 6 fine. Number of hydrogen 5 plus 2 called 7 and 1 9. So its formula is matching, right? That's it. Now, a small conversion chart for you. A small epic part only, because we are consolidating into 1 hour, 1.5 hours. Something. I'm not giving much, but you will get something, right? Regarding the conversion chart, see guys, I'm starting from here. RCH2OH. CH2OH means OH connected carbon, connected one other carbon, so called primary, primary alcohol. I'm passing this primary alcohol over, see, I'm passing this primary alcohol over strong oxidizing agents called KMnO4 in presence of H+. Maybe KMnO4 in presence of OH, any strong oxidizing agent, maybe KMnO4H+, KMnO4OH-, K2Cr2O7 in presence of H+, HNO3, H2CrO4, any strong oxidizing agent. Or CH2OH is called as primary alcohol passing over strong oxidizing agent KMnO4H+, KMnO4OH-, K2Cr2O7 in presence of H+, HNO3, H2Cr, any strong oxidizing agent. Primary alcohol will become carboxylic acid, CH2OH will become COH. Okay? Passing COH over ammonia. That you know, right? On passing over ammonia, this OH will take H from here, removed as water. Remaining will be RCO. From your OH, from your H gone, remaining will be your acetamide, RCONH2, called as acetamide. Passing this acetamide over, bromine in presence of NaOH. That bromine in presence of NaOH, bromine in presence of KOH is called Hofmann bromamide reaction, right? During that Hofmann bromamide reaction, CONH2 will become simply NH2, called as primary amine. I'm asking you, primary amine passing over HNO2, please. HNO2 is called as nitrous acid, prepared in situ by mixing NaNO2 plus, anyway it's HNO2, nitrous acid obtained by mixing NaNO2 plus HCl. Tell me, NH2 will become OH, right? NH2 will become OH. So starting from there, it's RCH2OH, called primary alcohol, with passing over any strong oxidizing agent. I'm using KMnO4 in presence of H plus. CH2OH will become COH, called as carboxylic acid. Passing over ammonia, this OH, H will be removed as water, getting acetamide, called as CONH2. Bromine NaOH is called as Hofmann bromamide reaction, will be giving you primary amine. Primary amine with HNO2 is called as R. But mamas, you know, this RNH2 giving ROH is applicable only for aliphatic primary amines, exclusively for aliphatic primary amine, exclusively for aliphatic primary amine only, exclusively for aliphatic primary amine. For example, ready? Ethanoic acid to methanol. See guys, whenever number of carbons are decreasing, eth to meth, or you can say eth to meth, I mean ethanol to methanol, ethanoic acid to meth, the thing that come in your mind should be Hofmann bromamide reaction. It will work almost. Whenever number of carbons are getting decreased, maybe eth to meth, I'm like, you know, ethanoic acid to methanol or ethanol to meth, the thing that come in your mind should be Hofmann bromamide reaction. For example, here, right? Ethanoic acid having formula CH3COOH, methanol formula CH3OH. During all conversion reaction, the change required is what, guys? COH into OH. The change required is COH into OH. Go back. How can we make into COH? Go this way. Go this way. Go this way. COH into OH. Go this way. Initially passing ammonia, acetamide, Hofmann, primary amine, alcohol by using HNO. It's applicable only for aliphatic primary amine, right? So take your ethanoic acid. Ethanoic acid formula CH3COH. Initially passing over NH3, called as ammonia. On passing ammonia, OH, H will be removed as water, getting CH3CONH2, called as acetamide. Whenever number of carbons getting decreasing, degradation, the thing that come in your mind should be Hofmann bromamide reaction, right? So this acetamide, I'm passing over bromine in presence of NaOH. On passing bromine in presence of NaOH, getting primary amine called CH3NH2, HNO, right? Passing over HNO2, this NH2 will become OH. Hope you are fine, I guess, right? If you have any confusion, just come in chat, I can clear it. Now it's called ethanol to methanol. Again, same, number of carbons getting decreasing. The thing that come in your mind should be Hofmann bromamide reaction. Take your ethanol. It's a 2-carbon alcohol formula, CH3CH2OH. To methanol, methanol is a 1-carbon alcohol formula, CH3OH. Cool, same, right? What we can do is CH2OH into OH. What we require the change is CH2OH into OH. CH2OH into OH means go this entire way. To make into CH2OH into OH. For converting CH2OH into OH, go this complete way. Initially passing strong oxidation, getting carboxylic acid, ammonia, acetamide, Hofmann, getting primary amine HNO, right? So go please, take your ethanol. It's a 2-carbon alcohol formula, CH3CH2OH. Initially undergo strong oxidation. Maybe KMnO4H plus, KMnO4OH minus, K2Cr2O7 in presence of H plus, HNO3, H2Cr4. I'm using KMnO4 in presence of H plus. On using KMnO4 in presence of H plus, that primary alcohol will become carboxylic acid. CH2OH will become COH. On passing over ammonia, that COH will become CONH2. COH will become CONH2. Go on, Huffman bromamide, please. During that Huffman bromamide reaction, CONH2 will become NH2, right? During that Huffman bromamide reaction, CONH2 will become NH2. NH2 on passing HNO2. NH2 on passing HNO2. NH2 will become OH. Hope it is clear for you, right? Carry on, next. Aromatic primary amine cannot be prepared by Gabriel thalamide synthesis. It's a give reason question. Aromatic primary amine cannot be prepared by Gabriel thalamide. What is meant by Gabriel thalamide synthesis? During Gabriel thalamide synthesis, benzene ring with COCONH called as thalamide. Benzene ring with COCONH called as thalamide will be initially passing over aqueous KOH. Starting from a compound called as THAC. My question is actually, a Gabriel thalamide synthesis cannot be used for preparing aromatic primary amine. Why? My question is, Gabriel thalamide synthesis cannot be used for preparing aromatic primary. Let's see what is meant by Gabriel thalamide synthesis. During that Gabriel thalamide synthesis, benzene ring with COCONH called as thalamide initially passing over aqueous KOH. On passing aqueous KOH, this H and OH will be removed as water. Remaining will be NK, getting benzene ring with COCO. NH will become NK. NK will be passing over RX. RX means alkyl halide. This NK will be passing over RX, alkyl halide. I can say this K and X will be removed as KX. NK will become NR. Getting benzene ring with COCONR. NR is same as RN. Will be passing over NaOH. Sodium hydroxide. Shortcut mechanism only. On passing NaOH, sodium hydroxide, this Rn same as Nr. Nr same as Rn, giving you RNH2 called primary amine. Remaining will be benzene ring with COCO will be connected by this NaO same as ONA. I hope it's finally here, I guess, right? During the Gabriel thalamide synthesis, starting from a compound called thalamide. Thalamide will be having formula benzene ring with COCONH initially passing aqueous KOH. This H and OH will be removed as water. NH will become NK. NK passing over RX, same as NK passing over RX. RX is called as alkyl halide. This reaction coming under SN reaction called as nucleophilic substitution reaction. Initially on getting NK, when this NK is passed over, this NK will be passed over RX called as alkyl halide called as SN reaction, nucleophilic substitution reaction. What happened means K and X will be removed as KX. NK will become NR. NR is same as RN, right? On passing over NaOH, this Rn will become RNH2. It's shortcut mechanism only. Rn will become RNH2 called primary amine. Remaining will be benzene ring with COCO will be connected by NaO as ONA. Opposite law will be having ONA here. My question for you, through these reactions, we cannot prepare aromatic primary amine. Why? If you want to prepare aromatic primary amine, instead RX, we'll be using aryl halide called benzene ring with X. But unfortunately, this aryl halide won't undergoes what? SN reaction. You know this reason, right? Because of partial double bond, right? So question is given that aromatic primary amine cannot be prepared by Gabriel thaliamides. This is give reason. So if I prepare aromatic primary amine, instead RX should get, we will be getting, a benzene ring with aryl halide. If you want to prepare aryl halide, if you want to prepare aromatic primary amine, instead alkyl halide, the chosen halide should be aryl halide, but aryl halide won't undergo this SN reaction. Hope you are fine. See, once again, guys, it's called it's actually the Gabriel thaliamide synthesis will be used for preparing aliphatic primary amine. If you want to prepare aromatic primary amine using same method, instead, if you want to get benzene ring with NH2 called as aromatic primary amine, instead alkyl halide, the chosen compound should be aryl halide. If you are using RX, we are getting RNH2. If you are choosing RX, getting RNH2 good. But if you want to get benzene ring with NH2 called as aromatic primary amine, instead alkyl halide, we should use aryl halide. If you are using alkyl halide, we are getting aliphatic primary amine. Okay. If you are using alkyl halide, we are getting aliphatic primary amine. Okay, instead that, if you are choosing aryl halide, expected product is aromatic primary amine, but unfortunately, this aryl halide won't undergo this SN reaction because of partial double bond. So I can say, if you want to prepare aromatic primary amine by Gabriel thaliamide synthesis, the chosen compound should be aryl halide, instead alkyl halide, but unfortunately, aryl halide won't undergo SN reaction. Hope it's clear, right? Clear. Now it's boiling point of amines. Okay. Regarding the boiling point, whatever may be the organic compound, maybe alcohol, maybe aldehyde, the first concern regarding the boiling point is molecular mass. And I can say that boiling point is directly proportional to molecular mass. Okay. The first criteria deciding the boiling point of a compound is molecular mass, whatever may be the organic compound. First criteria, okay, deciding the boiling point of a compound is molecular mass, and I can say that boiling point is directly proportional to the molecular mass. I can say boiling point is directly proportional to molecular mass. For example, imagine amines called, what we can say, CH3NH2. CH3NH2 or CH3CH2NH2 or CH3CH2CH2NH2. Here contains one carbon, here contain 2 carbon, here contain 3 carbon. I know the first criteria deciding the boiling point of a compound. I mean, discussing currently it's amine. Anyway, first criteria deciding the boiling point of amine is molecular mass, and I can say that boiling point is directly proportional to molecular mass. Here contain 3 carbon, here contain 2 carbon, here contain 1 carbon. So here contain more number of carbon. More carbon means more mass means more will be the boiling point. So I can say the order of boiling point will be high for this one, then this one, then this one. 1 carbon, 2 carbon, 3 carbon. But if molecular mass is same, then regarding the amine, it's amine. Okay, second criteria. First criteria is okay, boiling point is directly proportional to molecular mass, fine, cool. So more the molecular mass, more number of carbon means more will be the boiling point. Okay, but imagine, if molecular mass come to be same, they are called as isomers. If molecular mass come to be same, they are called isomers. For isomers, I can say the highest boiling point will be for primary amine, then secondary amine, then tertiary amine. Why? Simple logic. Primary amine is having formula RNH2. Secondary amine is having formula R2NH. Tertiary amine contains R3N. So here contain more number of H. So more number of H means more will be the H bonding. So more will be the boiling point. Okay. So first criteria deciding the boiling point of a compound is molecular mass. And I can say that boiling point is directly proportional to molecular mass. Okay, but if molecular mass come to be same, they are called as isomers. In case of isomers, I can say primary amine. For amines, I can say primary amine will be having more boiling point than secondary, then tertiary. For example, imagine imagine CH3, En, CH3, CH3, okay. Then CH3, CH2, NH, CH3. Then I can say CH3, CH2, CH2, NH2. Okay. So here number of carbon 3, number of carbon 3, number of carbon 3, same number of carbon. They are isomers, right? Regarding ice, I know guys, first criteria is molecular mass, okay, and boiling point is directly proportional to molecular mass, fine, but here molecular mass come to be same. If molecular mass come to be same, then check with primary, secondary, tertiary for amine. This NH2 called primary, this NH called secondary, this N called tertiary. So primary contain more number of H means more will be the H bonding, so more will be the force of attraction, so more will be the boiling point. So I can say here we'll be having the highest one, then the second one, then the third one. Fine, cool. Just one more point I'm adding over here. That's all regarding the boiling point. Regarding the boiling point of any organic compound, first criteria is molecular mass. And I know guys, boiling point is directly proportional to molecular mass. Fine. That's why here contain 3 carbon, 2 carbon, 1 carbon. So 3 carbon containing more carbon, more mass, more boiling point. Okay. If molecular mass come to be same, they are called as isomers. In case of isomers, I can say primary will be having, because primary contain more number of H, so more number of H bonding, so more will be the boiling point. Cool. Around one more point for you guys. See, you may know this regarding the entire organic compound. Regarding the entire organic compound, the order of boiling point is, regarding the entire organic compound, the order of boiling point is high will be for carboxylic acid. After carboxylic acid, alcohols will come. After carboxylic acid, alcohols will come. Then amines. The order will go on. I'm just focusing on last 3 members. Regarding the entire organic compound, high boiling point will be for carboxylic acid, alcohols, amines. Then go on. It have aldehydes, ketones, either. I'm just focusing last 3 members. Okay. So highest one will be for carboxylic acid. Then alcohol come. Then remember it's applicable for organic compound having comparable molecular mass. Okay. Regarding the organic compound having comparable molecular mass, high boiling point will be for carboxylic acid, then alcohol come, then amine. Simple example. Imagine CH3COH or CH3 CH2OH, then CH3 CH2NH2. I know it's a 2 carbon acid. It's a 2 carbon alcohol, it's a 2 carbon amine. Among acids, alcohols and amine, acid will be having high boiling point, then alcohol come. Then it depends upon actually H bonding, strength of H bonding. Carboxylic acid held by H bonding, alcohols held by H bonding, and amines is also held by H bonding. Okay, but H bonding observed in acid is the strongest one, then alcohol come, then amines come. That's it, right? So regarding the boiling point, first criteria, whatever may be the organic compound, first criteria deciding the boiling point of a compound is molecular mass. And I can say boiling point is directly proportional to molecular mass. So more number of carbon means more will be the mass, more will be the boiling point. Okay. If molecular mass come to be same, then primary will be having more boiling point, then secondary, then because primary contain more number of H, so more number of H bonding. But remember, regarding the entire organic compound having comparable molecular mass, high boiling point will be for acid, then alcohol, then amines. Okay, your question. Okay, it's a general case, exception may come. It's a general case, but exception may come. Let's see. General category is okay for you, I guess. Question given. Arrange the following in the increasing order of boiling point. Arrange the following in the increasing order of boiling point. First one, CH3 thrice N. Second one, C2H5OH. Third one, C2H5NH2. Right? It's a 3 carbon amine. It's a 2 carbon alcohol. It's a 2 carbon amine, right? It's a 3 carbon amine. It's a 2 carbon alcohol. It's a 2 I know guys, regarding amines and alcohol, first thing I'm sure, among the organic compound having comparable molecular mass, if alcohols and amines coming, alcohol will be having high boiling point. Okay, so alcohol called C2H5OH will be having high boiling point. Okay, because I know among alcohols and amine, alcohol will be having high boiling point. Fine. Regarding amine, It's a 2-carbonamine, it's a 3-carbon. I know guys, regarding the boiling point, first criteria is molecular mass. Here contain 2 carbon, here contain 3 carbon, here contain more carbon. More carbon means more mass means more the boiling point. Okay, so people may expect 3-carbonamine called CH3 thrice N will be having high boiling point than C2H5NH2. It's a 3-carbonamine. It's a 2-carbon alcohol. It's a 2-carbonamine. Fine. I know guys, regarding the alcohols and amine, alcohol will be having high boiling point. Okay. Here it's contain 3-carbonamine. It's a 2-carbonamine. Among 2-carbonamine and 3-carbonamine, first criteria deciding the boiling point is molecular mass, and people may think here contain 3 carbon, more mass, more boiling point, expected one, but actually found that this order is wrong. Experimentally proved that alcohol will be having high boiling point. Okay, alcohol will be having high boiling point. Okay, regarding 2-carbonamine and 3-carbonamine, exclusively for this exception case, only for this question, exception case, people may think if 2-carbon and 3-carbon come, 3-carbon contain more mass is more boiling point. Okay, but experimentally found that this 2-carbonamine is having high boiling point than this 3-carbonamine because it's primary having more extensive H bonding factor predominating the molecular mass. I know generally the first criteria is molecular mass. Okay, but for this question, rather than the molecular mass, H bonding is overcoming, predominating that molecular mass factor. Because of that, this primary amine called C2H5NH2 is having high boiling point than these 3-carbon one. In exception case, generally people may think, but for this question only, I can say 2-carbon alcohol will be having high boiling point. Okay, and when 2-carbon and 3-carbon, people may think 3-carbon is having more molecular mass. So, but the problem is, experimentally found that this 2-carbonamine is having high boiling point because of its H bonding factor. It's a primary amine. H bonding is strong, and H bonding is predominant that molecular mass factor. Hope you're getting right. It's a good one, nice one, right? Hope you got it. Next one. pKb value of aniline is more than that of, it's a give reason question actually. Give reason. Why? Give reason. pKb value of aniline is more than that of methylamine. Why? Or give reason. See, any question related to pKb and Kb come, the thing that come in your mind should be basicity. Amines are basic in nature. Primary amine called as RNH2. Secondary amine called as R2NH. Tertiary amine called as R3N. They all are basic in nature. Why? Because of the availability of lone pair. If availability of lone pair is increasing, it's Lewis base concept, it's lone pair, so Lewis base concept. And we can say amines are basic in nature. Maybe primary amine, secondary amine, tertiary amines are basic in nature because of their availability of lone pair. More lone pair. So if availability of lone pair is increasing, means basic nature will be increasing. If availability of lone pair is decreasing, means I can say basic nature will be decreasing. Cool, right? So it's primary amine, secondary amine, tertiary amine, all are basic in nature. Why they are basic means because of the availability of lone pair. Whether it is primary amine or secondary amine or tertiary amine, they all are basic in nature. Why they are basic means due to availability of lone pair. So simple logic, if availability of lone pair is increasing, basic nature will be increasing. If availability of lone pair decreasing means basic nature will be decreasing. Logic is amines are basic. Whether it is primary amine, secondary amine, tertiary amine is basic because of the availability of this lone pair. If availability of lone pair is increasing means basic nature will be increasing. If availability of lone pair decreasing means basic nature will be decreasing. Cool, calm, right? So my question for you, regarding the question, if any question come to pKb, Kb come, the thing that come in your mind should be basicity. Any question related to pKb, Kb come, the thing that come in your mind should be basicity. And I know guys, Kb value will be directly proportional to basicity, whereas pKb value will be inversely proportional to basicity. If any question related to basicity, or we can say Kb, pKb come, the thing that come in your mind should be basicity. And I know that Kb value will be directly proportional to basicity, whereas pKb value will be inversely proportional to basicity. We have two compound. One is aniline and one is methylamine. Okay, one is aniline and one is methylamine. Who is aniline means I can say benzene ring with the NH2 is called as aniline. One is methylamine called CH3NH2. One is benzene ring with NH2 called aniline. Second one is methylamine, that is CH3NH2, right? Both of them are basic in nature. Why? Because both of them are primary. Lone pairs are available. Because of that lone pair, they are basic in nature. Okay, fine. Good thing is that here contains methyl group, here contains a benzene ring. I can say benzene ring is electron withdrawing group. If electron withdrawing group is coming, they will be withdrawing electrons, so basic nature will be decreasing because amines are basic because of availability of lone pair. If aniline contains a benzene ring. Benzene ring is electron withdrawing group. They will be withdrawing electron. If they withdraw electron, basic nature will be decreasing. If basicity less means pKb value will be more. So any question related to Kb, pKb come, the thing that come in your mind should be basicity. Regarding the basicity, I can say guys, Kb value will be directly proportional to basicity, whereas pKb will be inversely proportional to basicity. In this, aniline contains a benzene ring. Benzene ring is electron withdrawing group. If electron withdrawing group minus I effect, electron withdraw, they will withdraw electrons, so availability of lone pair will be decreasing. If availability of lone pair is less, then basic nature will be less or pKb value will be more. Hope you find right. So any question related to Kb, pKb come, the thing that come in your mind should be basicity. And I know guys, Kb value will be directly proportional, whereas pKb will be inversely proportional to basicity. Questions clear, right? It contains aniline and methylamine. Aniline contains a benzene ring showing minus IFH. Colloquially, I can say electron withdrawing group. If they withdraw electron, availability of lone pair will be decreasing. So basic nature will be less or pKb value will be more. Hope you are fine, right? It's part 1. You will get part 2 soon. So just wait for remaining 8 more questions in your part 2 recording of Amine. Hope you enjoyed. We'll see you again for part 2 of Amine. Get ready. Thank you.